In this problem, we're asked to consider what happens when a stopcock is opened and gases are allowed to intermix. They want us to calculate the pressure of each gas individually and the total pressure. What's important to note is that Boyle's law would need to be applied for each of the gases individually, and then to calculate total pressure, we add the final pressures together. So let's first consider hydrogen. They give us that the initial volume is 2 liters and its initial pressure is 475 torr. When the stopcock is opened, the final volume of the total system, because the gases will be allowed to intermix, is 3 liters. Assume that none of the hydrogen molecules interfere with nitrogen molecules once the stopcock is open. The two types of gases will just intermix without any interference. So both of the gases have a final volume of 3 liters. Those 3 liters would be in the same space as the other gas. So Boyle's law for the hydrogen first. We'll use units of torr because it appears that Webassign wants us to answer in units of torr. Our final pressure is unknown, and the final volume is 3 liters. In the case for hydrogen, this number works out to be 317. In the case for nitrogen, we'll use the same setup, except Webassign's being a little pesky here. They give us the initial pressure of nitrogen in atmospheres, but they're going to ask for the final pressure in torr. Let's save ourselves a little bit of work by converting from atmospheres into torrs before using Boyle's law. You wouldn't have to do this. You could convert after using Boyle's law, but I think it's a little faster to do it this way. So 760 times 0.2 gives us 152 torr. Now let's use Boyle's law. The initial pressure is 152. The initial volume for the nitrogen was just 1 liter. The final pressure is what we'll solve for, and the final volume is in 3 liters of space. If we crunch the numbers, we get 50.7 torr. So we've got two of our answers right now, 317 and 50.7. To get total pressure, that's a little bit of Dalton's law. P total in this case would be the sum of the pressure due to hydrogen and the pressure due to nitrogen. Those are the only gases that we know about in this mixture, so we'll just add those two together now that they are occupying the same space. And we get 367.7 torr.